Okay, let's unpack this. Have you ever thought about putting, like, sticky notes inside your computer code?
Uh-huh.
Not, actual physical sticky notes, obviously, but something that acts just like them, providing extra context, maybe instructions, but without changing how the code actually runs.
That's a fantastic way to put it, actually. Yeah, it perfectly sets the stage for our deep dive
Oh,
today.
good.
We're talking about Java annotations, those powerful little markers. These become absolutely fundamental in modern Java development.
Right.
So our mission today is basically to explore the what, why, and how of these annotations. We're drawing from a pretty comprehensive guide for beginners here.
Okay.
And the goal is really to pull out the most important nuggets of knowledge and insight, making
Yeah.
you well informed on this crucial aspect without, drowning you in information overload.
Exactly. And we want to show you how these special tags, these markers, like maybe at override, which you might have seen around,
Yeah, that's a common one.
they aren't just decoration. They actually empower modern Java applications. They simplify really complex configurations and honestly just make the code clear, much more manageable, I think.
Definitely. So we'll start by defining what annotations actually are. Then we'll really dive into their uses, their advantages, which are quite a few.
Okay.
We'll even peek under the hood a bit, see how they work internally. We have to talk about their limitations too, the downsides.
Important point.
And finally, yeah, distill the essential stuff for anyone looking to, use them effectively in their own projects.
Great. So let's start with that sticky note idea again. Annotations in Java.
Mm,
They're essentially metadata, right? Information about the code
exactly.
introduced back in Java 5.
Hmm.
And you always spot them with that @ symbol.
Yep, the @ sign.
Now, what's crucial, I think, is that while they're defined using @ interface, that keyword,
Hmm.
you shouldn't confuse them with regular Java interfaces, the ones that define like method contracts.
That's a key distinction. Very important.
These are different. They're like a special kind of declaration just for carrying information about program elements, classes, methods, fields, parameters, whatever, without actually changing the element's behavior.
That's it. Perfect. And going back to the sticky note analogy, you attach them to parts of your program.
Right.
The notes don't change how the program runs, but they give critical extra context or instructions, primarily for tools.
Tools. Like what?
Well, think of the Java compiler itself, for starters. Or testing frameworks. JUnit is a big one.
Okay.
Or even application servers, the things that run your web applications. They all can read these annotations.
And these sticky notes, you can slap them on almost anything in the code.
Pretty much. You can apply them to whole classes, maybe marking one as a special configuration component for a framework.
Uh-huh.
They go on methods like that at override we keep mentioning. That tells the compiler, hey, this method should be overriding one from its parent.
Right. A safety check.
Exactly.
Yeah.
You can put them on fields too, maybe telling a tool how to serialize that field, how to save it, or even on method parameters or local variables. Like you could have an annotation indicating a parameter must not be null.
Wow. Okay. So quite versatile.
Very. And that leads us to why they're used so much. There are several core reasons. First, just providing that metadata information about the code.
Right.
It could be simple, like marking a method at deprecated, basically saying, don't use this anymore, it's old news.
We've all seen those.
Yeah, or it could be more complex, like telling a framework, this class needs this specific dependency injected here. Big stuff in frameworks like Spring.
And you mentioned the guide compilation. That @ override example again?
Precisely. It's not just a comment for humans. The compiler uses @ override. If you put it on a method that doesn't actually override anything, the compiler flags it as an error.
Ah, so it catches bugs early.
Catches a very common, sometimes tricky bug before you even run the code. Saves a lot of headache later.
I can imagine.
Then there's enabling tooling. This is huge. Modern frameworks, you mentioned Spring. There's also Hibernate for databases. JUnit for testing, they rely heavily on annotations.
Ah, so.
Well, they use them for configuration. Instead of writing tons of setup code or XML files, you just pop an annotation on your Java class or method,
Okay.
like mapping a Java class to a database table in Hibernate. You use annotations like @entity or @table, marking a method as a test case in JUnit. Just add @test.
So that
Look.
simplifies configuration massively. Less XML is usually a good thing.
Oh, definitely.
Right.
It gets rid of so much of that external configuration clutter. The setup information lives right there with the coded effects. Much easier to see what's going on.
And that leads to the last point, right? Code clarity.
Absolutely. The code becomes more self-descriptive. You see an annotation like, say, at read only on a method, and you immediately get a hint about its intent. It probably shouldn't be modifying data.
Okay, so for someone listening, the real takeaway here isn't just, oh, it makes code look nicer. It's that annotations are fundamental in big projects. They help manage complexity.
Exactly. They're like the hidden wiring, the architectural labels that make large-scale Java development manageable. They let teams build and maintain complex applications more effectively.
That makes sense.
Yeah, so that brings us nicely to the power-ups, you could say, the real advantages annotations bring to the table.
Okay.
And what's really fascinating here is how annotations act almost like shortcuts. They make development faster, less error-prone, especially when you're working with these big, modern Java frameworks.
Yeah, I can see that. The simplified code aspect is huge for me.
Yeah.
Reducing boilerplate, getting rid of those external config files,
Right.
like your Spring example,
Mhm.
just putting it component on a class and bam, it's registered as a bean, no more hunting through XML files. That's a big win.
It really is. And that directly improves readability too, doesn't it?
Yeah.
Well, because the metadata, the configuration is right there in the code. You don't have to jump between files to understand what a class or method is supposed to do in the context of the framework. It's more self-contained.
Makes sense. And the compile time checks, like at override, we keep coming back to that one.
A great example.
But catching errors early before runtime, that just improves reliability, period.
Hugely important. And then there's the framework integration itself. We've touched on this, but it's worth stressing.
Yeah.
Modern frameworks like Spring, Hibernate, JUnit, they are built around annotations. Using them makes leveraging these powerful frameworks much, much easier. The setup is minimal because the annotations handle it.
It really lowers the barrier to entry for using complex tools.
It does. Plus, there's flexibility. You're not just limited to the annotations Java or the frameworks provide. Developers can create their own custom annotations.
Really? For what?
Oh, all sorts of things. Maybe defining custom validation rules or triggering specific logging behavior or generating code automatically. It's quite powerful for specialized tasks.
Okay, this sounds a bit more advanced, though.
It is, yeah, but the possibility is there. And finally, there's tooling support. IDEs like IntelliJ or Eclipse, build tools like Maven or Gradle,
Yeah.
code analysis tools, they all understand annotations.
So they can help you more.
Exactly. They can use the annotation info to generate documentation, validate your code more effectively, automate builds or tests. It makes the whole development environment smarter.
Okay, so we've covered the what's metadata tags and the why, simpler code, better tooling, clarity. But now the big how. How does Java actually do this? What's happening behind the scenes with that little @ symbol?
Right, let's peek behind the curtain. So at their core, annotations are actually defined using that at interface keyword we mentioned. It looks a bit like defining a regular interface, but it's specifically for annotations.
Okay.
Inside that an interface definition, you can specify attributes. Think of them like parameters for the annotation. Common ones are value or name, things you can set when you apply the annotation to your code.
Got it. So you define the sticky note template first.
Precisely. And once you've defined it and used it, it goes through different processing stages depending on how it's configured.
Stages.
Yeah, there are basically three main points where annotations can be processed. First is compile time processing,
Like at override.
exactly like at override.
Yeah.
The Java compiler itself looks at the annotation during compilation. If you misused at override, it gives you a compile error right away. Early feedback.
That's good. What's next?
Then there's runtime processing. This is where things get really interesting for frameworks. If an annotation is marked with a special meta annotation called @retention, RU9,
At retention.
yeah, it tells Java how long to keep the annotation information around. Runtime means keep it in the compile.class file and make it available when the program is actually running.
Ah, okay.
This is crucial because frameworks like Spring or Hibernate can then use something called Java reflection at runtime.
Reflection. Sounds fancy.
It kind of is. Reflection is basically Java's ability to inspect its own code while it's running. So a framework can use reflection to look in class, see it has a certain annotation, and then configure itself or behave differently based on that annotation.
So it reads the sticky notes while the program is live.
Exactly. That's how Spring knows to inject a dependency, or Hibernate knows how to map a class to a database table, or JUnit knows which method to run as a @test.
Cool. And the third stage.
The third is source code processing. Some annotations are only needed during development. They might be marked with @retention. Sort, meaning tools might use them. Maybe a code generator looks at them to create some boilerplate code for you. But once compilation is done, the annotation information is just discarded. It doesn't even make it into the .class file.
Any examples of that?
A common one is at suppress warnings. You use that to tell a compiler, hey, I know you're giving me this specific warning, but I know what I'm doing, so just ignore it for this piece of code. The compiler uses it, then forgets about it.
Okay, so these retention policies, source, runtime are key. Is there another one?
There's one more, class. It means the annotation is stored in the .class file, but it's not available via reflection at runtime.
What's that used for?
It's less common, honestly. Sometimes used by bytecode manipulation tools or certain kinds of static analysis tools that look at the compiled code but don't need runtime access. For beginners, source and runtime are the main ones to grasp.
Got it. And you also mentioned at target.
Right, that's another meta annotation, one you put on your annotation definition. At target specifies where your annotation is allowed to be applied.
So you can say this annotation only works on methods.
Exactly. Or only on classes or fields or parameters. It lets you control the scope of where your annotation makes sense.
So this reflection API sounds like the secret sauce for runtime annotations, like X-ray vision for the code.
That's a good way to think about it. It lets frameworks look inside the running application, find those annotation instructions, and act on them dynamically.
Okay. And you mentioned annotation processors too, briefly.
Yeah, those are a bit more advanced. They hook into the compilation process itself.
How are they different from just compile time checking, like at override?
They can do more complex things. Instead of just checking rules, they can actually generate new source code files based on the annotations they find, or perform really sophisticated validation. Think of them as compiler plugins triggered by your annotations.
Wow. Okay, so boiling that down, annotations are instructions attached to code.
Yep.
And depending on how they're set up, the compiler or the runtime environment via reflection or special tools read these instructions.
And act accordingly. Enforcing rules, configuring frameworks, generating code. It's a powerful way for different parts of the system, including tools, to communicate through the code itself.
Very neat.
But, it's not all sunshine and roses, right? With great power comes, well, potential complexity and pitfalls.
The fine print. Okay.
Yeah. This raises that important question. While annotations are powerful, what are the trade-offs? What do we need to be aware of, especially if you're just starting out?
Good point. I imagine creating your own custom annotations isn't trivial.
Definitely not. Making custom annotations that actually do something often requires digging into that reflection API we talked about, or writing those annotation processors. That's a steep learning curve for beginners, requires a pretty solid understanding.
Okay, stick to using existing ones first. What else?
Well, there's the risk of annotation overload.
Overlord.
Yeah, just using too many annotations. If you sprinkle them everywhere, sometimes they can actually make the code harder to read, not easier, especially if the annotations are doing complex framework magic that obscures the basic logic.
So it becomes like a wall of symbols and you lose the actual code.
Exactly. You end up having to constantly look up what each annotation does and the underlying code flow gets hidden. It's a balance.
When do you know you've gone too far? Is there a rule of thumb?
It's subjective, but I'd say if the annotations start feeling like they're replacing clear, understandable code logic, or if they make it significantly harder to follow what a method actually does without knowing the framework intimately, you might be overdoing it. They should enhance clarity, ideally, not obscure it.
Okay.
Then there's runtime dependency. Those annotations processed at runtime using reflection.
Yeah.
Reflection, while powerful, generally has a performance overhead. It's typically slower than direct method calls or field access. In performance-critical sections, heavy reliance on reflection-based annotations could potentially be a bottleneck, usually minor, but something to be aware of.
Right, not free. What about what they can actually do? Are they limited?
They are. Annotations have limited expressiveness. They're designed to hold simple metadata strings, numbers, enums, class literals, even other annotations.
But not complex logic.
No, you can't put actual code logic or complex operations inside an annotation itself. They're just markers, labels with simple values. You still need regular Java code, or the frameworks interpreting the annotations, to perform the actual sophisticated tasks.
Okay. And debugging. Is that harder?
It can be, yeah. Errors related to annotations, maybe you forgot a required attribute or put it in the wrong place, often don't show up until runtime. Or worse, sometimes they show up during the framework startup phase, and the error messages can be a bit cryptic or hard to trace back to the specific annotation mistake you made. It can be frustrating.
I bet. And framework dependency, you mentioned things like springs at AutoWired.
Right. Many useful annotations are tied to specific frameworks. At AutoWired is Spring specific. At Entity is part of the Java Persistence API, often used with Hibernate.
So if you switch frameworks,
You might have a lot of annotation-related code to change or reconfigure. It can potentially reduce the portability of your core business logic if it's heavily intertwined with framework-specific annotations.
lock-in potential.
A little bit, yeah. And finally, let's be honest, there's just a learning curve, especially for beginners.
Definitely sounds like it.
Yeah, diving into a framework that uses annotations heavily means you need to learn not just the annotation itself, like what at service means, but also how that framework interprets and uses that annotation behind the scenes. It's 2 layers of learning.
Okay, so quite a few potential gotchas to keep in mind.
Important to be aware of them. Doesn't mean annotations aren't great, just that you need to use them thoughtfully.
So given all that, the power, the pitfalls, what's the action plan? If you're listening and you're relatively new to this, what do you really need to know to get started effectively?
Great question. The absolute best advice is start simple.
Okay.
Focus on the built-in Java annotations first. Get really comfortable with that override. Understand why it's useful. Learn about @deprecated for marking old code and @suppress warnings for managing compiler warnings.
The basics.
Exactly. They're straightforward, they demonstrate the core idea of metadata, and they don't involve complex frameworks yet. It's a safe place to start.
And then presumably move on to framework annotations.
Yes, because that's where you'll see the most in real-world code. Look at common ones. If you're doing testing, understand units @test, @before each, @after each. If you touch databases with JPA Hibernate, look at entity, @table, @IDA. If you use Spring, understand the core ones like @component, @service, @repository, @autowired.
See how they work in practice.
Right. See how they replace other forms of configuration and what problems they solve in those specific contexts.
And you mentioned understanding retention and target is crucial.
Absolutely vital. Knowing whether an annotation is processed at compile time, source, or runtime, and knowing where it can be applied at target methods, classes, etc., is fundamental to understanding how and why it works, especially within a framework.
Okay. What about that overload problem?
Be mindful of it. Avoid over-reliance. Use annotations where they genuinely add value, simplifying configuration, providing essential metadata, but don't use them to replace clear, well-structured Java code. Find the right balance. Clarity is key.
And reflection. You said be careful there.
Yes, especially for beginners. Understanding how frameworks use reflection to process annotations is good background knowledge. But trying to use reflection yourself to process annotations is definitely more advanced. Focus on using existing annotations correctly first. Leave writing reflection-based code for later.
Makes sense. Test everything.
Always. Because mistakes in annotations can lead to those tricky runtime errors, testing is crucial. Make sure your annotations are configured correctly and that the framework is behaving as you expect based on them. Write unit tests, integration tests.
Read the docs.
Oh, absolutely essential. Since so many powerful annotations are framework-specific, the official documentation for Spring, Hibernate, JUnit, whatever you're using, is your best friend. It will explain exactly what each annotation does, what attributes it takes, and how the framework uses it.
Don't just guess based on the name.
Please don't, yeah. And finally, regarding custom annotations.
Hold off for a bit.
Yeah, be cautious. It's a powerful feature, but it's definitely an advanced topic. Get really comfortable using the standard and framework annotations before you even think about creating your own. That involves understanding annotation processors and potentially reflection, which is, again, complex.
Okay, so wrapping that beginner advice up, start built in. Learn common framework ones, understand retention target, don't overuse, test well, read docs, and maybe table custom ones for later.
That's a perfect summary. So for you listening, the key takeaway is annotations are a really powerful tool in Java. They add metadata, they simplify configuration, they enable framework integration, they improve code reliability. They're everywhere in modern Java.
But they have challenges.
But they come with challenges, potential complexity, overuse, debugging hurdles. So start experimenting, but do it thoughtfully. Use them to write cleaner, more maintainable code.
Yeah, this whole deep dive, it really feels like it's shown you, the listener, a fundamental way that Java code talks to itself, talks to tools, configures complex systems. It really makes large-scale development seem much more manageable.
It pulls back the curtain a bit.
It really does.
Hmm.
And if you connect this to the bigger picture, annotations are a great example of how modern programming tries to shift complexity. Instead of massive external configuration files or verbose setup code,
Yeah.
you move towards concise, meaningful metadata embedded right in the code. It's about writing code that speaks volumes about its purpose and its role in the larger system, not just code that executes commands.
It's a great way to put it, code that speaks volumes. But
Mhm.
thinking about those limitations you mentioned, like limited expressiveness, only simple values,
Uh-huh.
and that risk of annotation overload where things get cluttered,
Mhm.
it makes me wonder what comes next.
If annotations have these boundaries, how might future programming languages, or maybe future versions of frameworks, evolve beyond annotations? How could they achieve even greater code clarity, even smoother tool integration, simpler configuration, without falling into maybe a new kind of overload trap?
That is a fascinating question to ponder. What does the evolution look like?
Something for you to think about. Thank you for joining us on this deep dive.